Welcome, geometry students. Today we're going to learn how to prove theorems about perpendicular lines. So the first thing I want you to do is draw a horizontal line. So horizontal lines run left to right with the horizon. And then I want you to draw a smiley face somewhere above that line. It says, how would you calculate the shortest, would you please correct my typo? The shortest distance from the smiley face to the line. Well, if you think about how far that smiley face is to the line on this point, that might be different from how far the smiley face is from the line on that point. So the reality is I could draw a line to that smiley face to an infinite number of points on that line. None of those are going to give the same distance. As I go further away from the smiley face, it's going to be a larger distance. So when we're calculating a distance, we're always going to calculate it so that it makes a perpendicular with the line that we're looking for the distance from. So just keep in mind as you're asked to find distances from a line that you always want to make sure that that distance will make a perpendicular with what you're looking for the distance from. All right, we have two properties we're going to learn about perpendicular lines. First property states if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Keep in mind the symbol for perpendicular is an upside down capital T. Now let's do a little review. We said linear pair is a pair of angles that makes a line. In other words, if we look at this, they're adjacent supplementary angles. So this linear pair of angles, we would know that x plus y would add to equal 180 degrees. Now property 1 here is telling us that there's a little bit more required than just a linear pair. It specifically states that it's a linear pair of congruent angles. So let's think about this. We still need to hold the requirements of a linear pair. So they have to be supplementary and they have to be adjacent. But the only way for those two angles to be supplementary, adjacent, and congruent would be for those two angles to have what angle measure? Well, the only angle measure that would work would be a pair of angles that were each 90 degrees, because any other congruent relationship would not add to be 180. So we know according to this that these two angles are a linear pair of congruent angles. So our conclusion is that these two would be perpendicular. And as we know about perpendicular, they form right angles. Property 2 states if two lines are perpendicular, then they intersect to form four right angles. And that's something that we've learned before. So for example, if we have line A intersecting line B, and A is perpendicular to B, then we can conclude that all of these angles will be right angles. All right, let's take a look at example 1. Example 1 says, explain how you know that the angles have specific properties. In other words, in the diagram, angle 1 is given to be congruent to angle 2. We need to prove that angle 3 and angle 4 are complementary using complete sentences. All right, we did algebraic proofs earlier in this unit, and essentially what we did is we did our algebra and solved the equation, but then we provided a reason for that in a T-chart form. What we're going to do here is we're going to use a paragraph proof and use complete sentences to show how angle 3 and angle 4 are going to be complementary. So here's the big idea with a proof. You're going to be given either a fact or multiple facts. In this case, we were given angle 1 is congruent to angle 2. And we're asked to prove that angle 3 and angle 4 are complementary. So prove angle 3 and angle 4 are complementary. So here's how it works. The beginning is what you're given. So we're going to begin here. And we're going to end once we get to the point that angle 3 and angle 4 are complementary. Sometimes it's helpful to think backwards through this process and begin with the end, and other times it's helpful just to start with what you're given. So I'll leave that up to you, and you'll gain more of a better understanding of that as we do more of these. So for right now, let's start with the beginning. Our introductory sentence should say something like, we are given, and then you'll state whatever fact or facts you were provided with. So the only thing we were told in this case is that angle 1 is congruent to angle 2. And if we look over here on our picture, there's the markings that show that those two angles are congruent. Now if you notice, we're trying to have the ultimate goal of showing that angle 3 and angle 4 are complementary. So really, we're going to have to show that angle QPS is a right angle. So that's our goal. So let's think about how we can use angle 1 and angle 2 to do that. Well, if you notice, angle 1 and angle 2 are congruent angles, but they also form a linear pair. So I want you to stop and think, what do we know about angles that are congruent and form a linear pair? Well, from property 1 a bit ago, we learned that those would make the lines intersecting perpendicular lines because those would have to be right angles. So what we're going to do is we're going to establish that now. So since we're given angle 1 is congruent to angle 2, we can go on to show that QV, line QV, is perpendicular to line PS. Let's do that now. Next, we can show line QP. Now keep in mind that line could have also been named as line PQ or PV or QV. Any 2 points on that line is acceptable to use. So we can show line QP is perpendicular to line PS. Now, we've claimed that those are perpendicular, but we have not given any justification. So when you're doing a proof, you need to make a statement, there's our statement, and then you need to provide a reason for it. And your reason is going to be in the form of one of our definitions or properties or theorems that we're going to learn. Well, we're going to use property 1 that we learned earlier today, but we're not going to just write property 1. And the reason for that is we've named it property 1. That's not a universal label. So at another school, they might be calling it property 7. So we will never use the numbers of our theorems or properties in our proofs. We're going to actually write it out. That will also help us because we're putting it in our own words and making sense of the properties. So next we can show that these two lines are perpendicular, since angle 1 and angle 2 are congruent and a linear pair. So we know that those are going to be perpendicular. So when we look at our picture, we've now established that line QV and line PS are perpendicular. And don't we know that perpendicular means that all of those angles are going to be right angles? So now we're going to use our definition of perpendicular to show that angle QPS is a right angle. Keep in mind our main goal is to prove that angles 3 and 4 are complementary. So if we can show that this is a right angle, that's very, very helpful. So we're going to go on to say that we know by the definition, you can abbreviate definition as DEF, by the definition of perpendicular lines, angle QPS is a right angle. Now, when we think about complementary, we need to show that those two angles add to be 90 degrees. So isn't it true that if it's a right angle, that would mean angle QPS is 90 degrees? So essentially, we have enough information to show that angle 3 and angle 4 are complementary. So we're going to go on to say, since angle QPS is a right angle, we know its measure is 90 degrees. Now that's what we're claiming. Now we need a justification. And so we know it's 90 degrees by the definition of right angle. If you remember earlier, I said details are so important. So that might seem like common knowledge to you. We all know that a right angle means it has 90 degrees. But even though it's common knowledge to us does not mean it's common knowledge to any reader that would pick up our explanation. So we want this to be explained in such detail that anyone can follow the steps. So now anyone who doesn't know a right angle is 90 degrees is going to know that by the definition of right angle. Therefore, angle 3 and angle 4 are complementary since they add to be 90 degrees. So if we look at this, we've gotten to our ending. We've decided that they are complementary because we've established that they add to be 90 degrees. So that's our proof for this particular example. Now, these paragraph proofs are not going to be something you're going to be able to do necessarily immediately. So it might take some practice. So please be aware if something is still a little bit, if you're still a little bit unsure about any of those steps, that we will continue to practice these paragraph proofs and you will continue to get better and better over time. So just stick with it and ask questions if you have them. Go ahead and try the You Try Now, and we'll do more with paragraph proofs in class the next time we meet. Thanks so much for joining me and have a good day.